Okay, hi everyone. So thanks very much for the introduction. I'm Joe McGrath. That's my Twitter handle, and what I'm here to talk to you about is my experiences working alongside machine learning or AI engineers to try and start productionizing and operationalizing, if that's a word, AI in the digital services that we kind of build for our customers, and trying to help our customers also start doing that themselves. Hopefully you'll find value in it. I might not have a lot of time for questions at the end, but as Jessica said, same thing. Grab me in the corridor, grab me at lunch, and I'm happy to answer any questions. So a bit about me. I am not an AI ML specialist. I don't have the mathematical ability to follow anything but the basics. Literally, I get lost very, very quickly. I am a cloud or solution architect at Kainos Software, who you may or may not have heard of. I have an old school infrastructure background, so I did plug network cables into data centers and things way back in the day. And I got involved, sort of wanted to get involved in this because it was an interesting challenge. I was at a conference about this time last year, and a number of speakers sort of covered this, and it wasn't a solved challenge at that point. That was by Google, AWS, Microsoft, Facebook. Any big tech company are basically struggling to, well, not struggling, but they're all still working towards it. And it was a case of right place, right time. We had a nascent AI practice in Kainos, and I sort of injected myself into this to try and kind of accelerate that in the company itself. And I also do get bored very quickly, so I like to change what I'm doing every few years, and again, that was the opportunity to do it. So why now? Well, I kind of work usually, luckily enough, in DevOps teams where developers and operations sit close together. We've got QA, product specialists, user researchers, multifunctional teams, all working closely together to deliver digital services. But the data scientists don't sit in that team. They sit off to the side. They're involved at the start, refining data models, getting the data structures in place, and then they kind of hang around and do other things until we have production data, and the customers want some business intelligence, and they want to kind of leverage that data, and the data scientist comes in and takes the data and runs offline reports and generates kind of reports that then help the business make decisions. But they're not really involved in the teams, but something's changed, and that thing is AI. It has been around for decades, believe it or not. There have been many false dawns, but now, thanks to the pretty much unlimited computing power from the cloud, as well as the unprecedented amount of data and the access to data that we have, customers, businesses, government are now wanting to leverage that data to improve experiences for citizens, to improve their decision making, and to also kind of improve experiences, take some lower value tasks off their staff, boring, repeatable kind of checking forms. Is this thing checked? Is this thing checked? To allow them to focus on higher value tasks, making sure that the organizations are getting more bang for their buck for the person that they are hiring. But for us as service delivery teams, and also the machine learning engineers, there's kind of a number of things up on the slide deck there. It does mean that we have new challenges. So from the traditional DevOps teams, we have a bunch of new artifacts that we need to understand, a bunch of new things that we need to deploy. QA need to understand how to test it. There's a whole raft of changes from our perspective. And it also entirely pretty much changes the way that data science and machine learning is done. Up until this point, it has predominantly been a fairly isolated kind of way of working. They do sit off in the corner and work away in R or Python and their tooling, and then kind of produce artifacts at the end with nobody really knowing how that happens. So that's kind of why I got interested in it. So the problems that I kind of encountered, first of all, were that, well, data management, which includes the models and things, is a non-trivial problem. As I stated before, data science is a fairly isolated and kind of, it's a one person working. The tooling doesn't really support collaboration, which I've said there as well. And the same thing goes for building, testing, and deployment. They've never really had to think about production because they've never had to really integrate with a digital service that sits in front of a customer, a web service, something that their colleagues in other line of business areas are working on. They've never really had to think about that. So we have a few problems, and the first one of those is data. That is the big problem. Without data, you don't have data science. Without data science, you don't have AI and machine learning. So you have to solve the data problem. And the first problem is that development data is no longer good enough. When we're building services, we generally don't give people access to production data, right? We don't want people to have access to that data, especially in certain fields. Medical fields, if it's financial data, customer data, we don't want every developer in the company to have access to that. But that won't work for machine learning and artificial intelligence. The machine learning models have to be trained on data that is production or as close to production-like as you can get. You can't think that you know what the data is going to look like, or your models won't work and your AI won't work. So we have to think about how do we manage that sort of data in a development environment, and that's tricky. The other thing we need to make sure is that we have enough data. If you don't have enough data, then you can't train your models accurately. But not just that, any data that you have has to be chunked up into 3 sets. You have training data that is used to train the model, you have testing data, which is used to test that your training has worked, and then you have a secret, super sneaky third set, which is validation data that your machine learning experts should never ever see, because that's what we use as DevOps teams or developers or QA to actually validate that that's working properly. So even though you think you might have enough data, once you chunk it up, you might find that you don't. You also need to make sure that it's appropriate. It is production data, but if you're working on a medical imaging AI that determines if somebody has a fracture in their arm by looking at digital X-ray images, well, you don't need the patient's name and date of birth and medical history, so you need to make sure that that's stripped out, but you still have enough data for the AI service that you're trying to build. So that's another thing that you need to check. You also need to think about who should have access to it. Does everybody need to have access to it? Does the actual machine learning engineer, who may be separate from the data scientist, who is doing the preparation and understanding of the work, need to have access to it? Or can that be controlled better? You also need to think about if you need to copy it, because if you've got a data set from a customer, what you will need to do is you might want to keep that in a safe place. So once data has been transformed and loaded, if there's been a mistake, you can start again from scratch. So again, you'll want to secure that and make sure that nobody else has access to it. It's a non-trivial problem, especially because this data can often, if it's video or image, you're talking petabytes potentially in size of the data that you have to manage and move around the place for multiple developers to have access to. That's a sea change from even the largest possible binary objects that we've ever had to manage before. The next thing is model management. The model is the AI. That is what goes into production. It is tightly coupled to the data, so if you've performed extracting and transformation on the data, then the version of the model is created by that data. To replicate that model, you'll need to start again with exactly the same data. If you lose the data that you've configured the model to accept, then you can't recreate the model. So you can't, unless you have the code, it's very, very difficult to do that. So you need to think as well where you're going to store your models. Yeah, don't do that. That was 4 models loaded into GitLab, a customer managed GitLab, so not hosted. As soon as you start creating multiple branches, so if 2 people work on that and then push it back up, well then you've got 1.4 gig, and then somebody else does it again and you've got 3.6, and somebody else does it again and you've got 4.8, and your GitLab server just quickly runs out of space, and your enablement team comes banging in the door saying, what the fronts do you think you're doing? That was an innocent mistake. We had started collaborating with some data scientists, and they thought, well, this is where I put my code, so this is where I should put my models. That was an education thing. It didn't take much to fix, but don't do that. So it has similar issues to data management. The AI engineers can iterate through multiple models. They'll create loads of them and test them. While they're testing their hypotheses, they will have created different algorithms. They'll be trying different types of machine learning approaches to crack the nut. And the other problem that you will have is that data scientists love refining the data model. They're never really happy. They want to strive for 99.99995% accuracy. That's what they want. They don't really think good enough's good enough. So you could have 10, 11, 12, or fewer or more. And the other problem is these models can be many hundreds of meg in size. So again, much, much larger than the binary objects or jars or the current trend towards microservices as small deployable units as possible. This is completely blowing things up the other way. So we need to think about that. And versioning is non-trivial. So this is a screenshot of a piece of code when one of our machine learning engineers was generating models. That was not the final weights file. I think there was 3 or 4 models created after this, but that's what the code remained. They didn't update the version number manually in their code, so we didn't know which one was actually the final one, and I'll get onto that in a minute why. And also, as I said, the model is very closely coupled with the data. So as well as managing your data version, you have to manage the model version and the data transformation code, because the model is tightly coupled to that code as well. It will expect the data in a very, very specific format, and if you lose the code, or it's stored in a different location and you're not sure where it is, when it comes to productionizing, you'll have to reverse engineer the entire model or start again in order to make sure that you have the correct pre-processing code in place to make your model usable. So what options do we have for that and data? Well, the cloud, right? It's pretty much unlimited storage. S3, Azure, anything like that, just fire it up there, give people access to it. You also have Artifactory. So we could pop things in there. You know, that's a well-known artifact repository. Have an automation job that I've also called out here in order to create the models. And one of the things that will enforce is the good practice, and it'll also ensure visibility of results when we're building our models. These are all currently being done locally on a developer's machine, which means that we don't really know how they've been built, what tests have been run against them, and kind of what data has been used to do that. It does get a little bit tricky. Collaboration, right? That's DevOps. We all work together. We need to bring the data scientists into our team. We need to start educating them in the ways that we currently work. We need to try and bring the best practices that we have honed over years of working together as QA, developers, operations, user researchers, site reliability engineers, you name it, we all try and work together apart from the data scientists. But there are a few challenges. The third pane is kind of the traditional way that data scientists sort of operate, collaborate, and version their code. It's all stored locally on their desktop in files like test or something underscored back or final, as I had before. This, to be honest, was sent to me by a colleague who saw it at a conference, and he thought it was funny because his desktop was actually way worse. He had millions of things all over the place, and he was basically checking the dates as to when the files were last accessed to try and figure out what was the right version of the code in the model that he could give to me. I am being a little bit facetious, to be honest. You know, not everybody's as bad. But basically, the other problem that it does highlight, again, is that model and data management. The model would all be stored locally on their development machine, usually a laptop, and if that goes bang, then all that work's lost. They're not really used to sharing stuff because, again, it is that solitary pursuit. But there might be valid reasons for this, and one of those is tooling. So this is a Jupyter notebook. I don't know if anybody's aware of Jupyter, but it is pretty much the de facto standard for machine learning data science work. It's used by everybody from AWS, Google, Microsoft, Facebook. They're AI engineers who are in the bleeding edge, right down to people who are going into university, just getting started in this process. This is the tooling that they get introduced to. And it is quite messy. So that's the output of running one of the cells. And the problem with this is that if you are working in this with GitOps, as we usually do, and you push this to your Git branch, well, all that lovely output goes into your diff. So even if you don't change the code, that output sits in the diff if you don't do anything to change it. It can make it incredibly difficult to review code changes because you'll have all this information here. You'll also maybe have noticed some security issues with it if you look a little bit closer. If you store variables and such as credentials in there, they'll also appear in your output. So again, you might have a security risk if you push that into Git. It's not great. So as I said, the tools themselves are very much skewed towards research and academia. The other thing is, this is where they will generate the models, but you wouldn't ever run a Jupyter notebook as your endpoint. There's no thought given to how the models will actually run in a production environment. That has to happen later, hopefully. The kind of third problem with collaboration is the development environment. Development environments for machine learning kind of turn things on their head. Your development environments have to be much, much larger than production. Training takes a lot of resources. That's why these GPU machines exist on AWS and Azure. That's pretty much what they're predominantly used for. Or you can go like right down into the floating point GPA enabled ones, which cost even more money and are very, very specialist. But your model to run in production doesn't need that many resources. That's just for training. That scares ops people whenever somebody says, I need a massive VM with 560 gig of RAM and 4 GPUs because I've got this massive neural net that I need to use to kind of scan videos and pick out different bits and pieces. That's not what we want. We want to give people MacBooks and say, you're writing very lean code, you don't need all that resource, production's the big thing. The other difference is that because everything generally happens locally, data scientists aren't really developers, so they don't have that mindset. They don't think about the dependencies. If they think they need a library, they'll pull it down. They'll install it. It means that things can get quite messy. And for another engineer to replicate the experiments, they basically go back to the Jupyter notebook and they get an error message and they go, oh, I need to install this thing, and they'll do pip install thing, and then they'll try and run the next cell again, and it'll error again and go, pip install this thing, and do that, and do that, and do that. It makes it very, very difficult for the work to be replicated until the other engineer gets out of dependency hell. And that then might actually break their own experiments because they've changed the version of a library that's been installed and can cause problems. And also, Python is kind of one of the languages of choice, but I have still seen version 2.7 in use, so like that generally give other people the heebie-jeebies. And that's for libraries for machine learning. Certain TensorFlow libraries are only supported in version 2.7, and the data scientists kind of refuse to update their code, unfortunately. I've already sort of touched on it. So this XKCD cartoon used to be, hey, my code's compiling, right? Because that used to take a long time. To be honest, this is actually legitimate. Model training has taken, at times, about 3 or 4 days, I've seen in some of the projects I'm working on. And I've already touched on it. It can be more resource intensive. So GPUs required. It costs money. And again, some organizations get scared at that. It's sort of different from the normal developer tooling that we're used to providing for our developers. And oft I've heard from data scientists that ops don't know what we want. They just sort of give us a big VM and then leave us be. So there's no configuration management on those development environments either, which is a little bit annoying. But we can do stuff, right? We've solved these problems before. This is what DevOps is all about. So for Jupyter notebooks and the environments problem, you can configure Git hooks. Jupyter itself has a little command called nbconvert, which will strip out all that output that you've seen before, pop it into a HTML file. It can also natively strip out the code, put it into a nice Python file for you, and give you a blank Jupyter notebook for the next engineer to use. It takes a little bit of work. It's not much. I found one on the internet, I've pulled it down. We're using it in Kainos. Also environment makefiles. So whenever you instantiate a new Git repo, have a makefile that creates a dummy environment file that then loads a new Conda environment for the machine learning to happen. That keeps all your dependencies nice and neat in there. It means that if we do the third thing, automate the model training and builds, it forces the machine learning engineers to work in that way because they won't be training and building on their local machines. We'll be standing up a build agent, Dockerized build agent, to do the training and the model building in there. And we need to know what those dependencies are. It starts to force those best practices. We could investigate other tooling. So there is tooling out there. Google, Microsoft, and AWS provide tooling to allow easier collaboration, SageMaker and Databricks being two of them. And we can also provide the suitable resources. Yes, this takes huge resource, more than we are used to providing, but it's something we're just going to have to bite the bullet and get used to doing. So what might collaboration look like? So this is kind of something that I drafted up. It's not using any particular tooling. It's based on Git hooks and kind of storage endpoints, so S3 or Azure Blob storage, and dependent on some decision points that are made, the data transfer, the model promotion, all happens automatically. You're not relying on any sort of data scientist to remember that they have to copy the data from A to B, they need to copy the model from their local machine up to a particular endpoint, and they need to version it. It can all be done automatically. We have the technology. It's more about the process. It's more about enabling the various processes that are here. The technology is relatively simple, I've always said. So we've got to this point. The developers, the machine learning expert and the development team have started working together, and we've got models. Seen this? Yep, this is the normal. This is the norm once you've got a model. Recently, a data scientist for a customer told me whenever I asked him about productionizing his model, he said, well, my model's done. Like, that's me. Boop, over the wall. There you go. You sort it out. Yeah, that unfortunately is standard. The reason being, they've never really had to think about production before. The models run locally. They've proved their experiments. Confidence is high. Accuracy is really good because they spent 6 months iterating, and throwing more and more kind of compute at it until they can get the confidence and the accuracy really, really high. But having the model is only half the battle. Yeah, so you've possibly heard of ETL, so extract, transform, and load, and that's kind of also the data prep code. So normally, most of the AI we work on and at how the machine learning is done locally or in a development environment, it's kind of set up for batch processing. That's just kind of the way that it works. But there's a huge drive now for real-time inference. And that means we need to change the code that the data scientist has mangled together to kind of prepare the input code in a way for their model to work. And that just won't work wrapped in an API, because that's not what that's not how they built it. This is more naturally a software engineering problem, and that's where your software engineers and your machine learning specialists have to come together to start understanding what it takes to get this to work. I've kind of said here that machine learning engineers are not software engineers, and that's because they have different concerns. Machine learning experts have never had to think about where it's going to run, and that's what we have to start them thinking about. And again, the data prep code is closely coupled to the model. So we'll get our engineers, they'll sit down together and pair program. That's one of the best ways for doing this, is actually getting the machine learning engineer to sit beside the software developer and the ops engineer and start understanding the concerns. The software engineer and the ops engineer have the machine learning expert to ask questions to, such as what transformations are here, what libraries have you used to prepare the data, what does the output look like, and we can sit down and all figure out what this might look like in terms of production wrapped in an API. Once it goes there. Best way I find to deploy these things, it'll not come as any surprise, is in a Docker container. It's wrap it in that. It simplifies the deployment, it makes it a single unit. We can do it all offline, and then the unit of deployment into production, or test, or staging, or Dave, or Bob, or whatever you call your environments, is a Docker which hosts an API, such as Flask, TensorFlow Serving, or Fast API. You could use other services, AWS SageMaker, Azure Databricks, Google Machine Learning Engine, although I think that's changed recently as what it's called. But they all use containers anyway, so you're not doing anything different than the big boys are doing. What they do, however, give you is the orchestration. They take away the management of the infrastructure. You no longer have to manage a Kubernetes cluster to deploy your model into. AWS, Microsoft, they'll do that for you. That undifferentiated heavy lifting, which is kind of their model. But before we deploy it, we have a few other things that we need to think about. We need to secure it. So the standard ways of securing AI are still there. You've wrapped it in an API. You need to make sure your API is secure. So authorization, authentication, TLS at the edge, if possible. We also need to make sure that our pipeline is secure. We would still be doing that. Your data, again, comes back to data. It always does. Your service is only as good as the data that it's trained on, and if somebody can modify your data, well then they can change what your AI does. They can change your model, so you want to make sure that your data is secure. You'll also want to sanitize your inputs, so you don't want it to go rogue. Depending on what it is, that is or isn't a problem, but if people remember Tay, the Microsoft chatbot that went a little bit right-wing, because people started figuring out how they could get it to say nasty things, depending on what your service is, you want to make sure that something like that doesn't happen. So yeah, we need to secure it in multiple different ways. How do we test it? Yeah, well, testing's a non-trivial problem because there are a lot of different aspects to it. Before we even get to integration testing, performance testing, security testing, any of that stuff, we need to actually validate and verify that the model does what we need it to do. But that's not very easily done through automated testing. We need to have a human in the loop, because there's a lot of gut feeling, there's a lot of analyzing the outputs to understand, well, the accuracy and the confidence. There might be times when we when we accept lower confidence because actually the model's more accurate. But that's very, very difficult to automate. So at the minute, the data scientist and the machine learning expert do have to be involved at that stage, unfortunately. But again, they also need to test for over or under fitting. So if the model's too complex or too simple, again, that's a gut feeling. It's not easy to automate that away. But we have experts in testing, right? We have QAs. Get them involved. Get them sitting with the machine learning experts. Sit down, understand what the requirements are, and see how best we can do it. Monitoring, alerting. The models are stupid. Well, they're very, very smart, but they're stupid. They don't know how to log. It's not built into them. So again, your API will have to understand if there are failure states coming out of the model. You'll need to make sure that you're monitoring and alerting those, checking for the confidence, how confident it is over time. Is confidence changing? Is confidence going up or down? So again, that's something the entire team have to collaborate on to make sure that you can understand what's going on in your monitoring, in your service. So, tried this. Yep, we had everybody in place, entire team, architects, developers, ops, no QA. We had all the right people together. We were generating billing codes based on some natural language processing, so information that somebody had entered into a system, the models would parse, and then they would spit out a specific code that could be used to bill. 8-week deadline. The models had all been built before. They'd been tested, proof of concept locally in the data scientist machine. We were super confident that the models worked. Initially, they just needed refined. What could possibly go wrong? You know, we had everything there. We knew what we were doing. After initial kickoff, where everybody thought that we knew what we were supposed to be doing, everybody split off into their natural silos. The data scientists and the AI engineers sort of disappeared off for 8 weeks, refining, wanting to get it as super accurate as possible. The ops, architect, and developer sat off in another corner building the proof of concept web service, the two endpoints that we wanted to hit, and also a little naughty GUI just to output the results. We got to 3 days before we were due to show this to the customer, and we still hadn't had the models. We still didn't know how they worked. And the data scientists turned around and said, "We have 8 models for you to use," and we were 8. We were expecting at most 2. We had to try and figure out how we could orchestrate those. But actually, worse than that, 2 data scientists had worked in 2 entirely different ways, so their 8 models all required different inputs from each other, so we had no common way of integrating the models with the service. We thought we had all the right people. We thought we knew how we were working. But we learned you have to define your contracts early. You need to understand the data and what inputs and outputs might look like. Mocking is a necessary evil for the software side. And also, good enough is good enough. The machine learning engineers want to refine the data model. As I said, they are super, super keen to get it as accurate as possible. That's what they want to do. But that means 2 different things. They can go super accurate, but they might need a massive, massive machine to run this. Some of the cheapest machine learning VMs on AWS to run for a month are about $3,000. And that's just for one real-time inference thing. So you maybe want to scale that up. All of a sudden you have 6. So a month, that's $18,000. Multiplied out by a year, you're soon into megabucks. But that machine might only be necessary for a percentage or a less than a percentage point change in accuracy. If you can change the model and use a much smaller machine and still get an acceptable level of accuracy, then you're going to be saving money. Oh yeah, and communicate. It seems obvious, right? This is what we've been talking about today. But the new skills for your ML engineers, all the stuff our software delivery teams take for granted, all the non-functional requirements, all the things that kind of ops have taught software engineers and software engineers have taught ops, we now need to kind of bring the AI and ML engineers on as well. But we also have a bunch of stuff that we need to start understanding as well. There's new technologies, there's new terminology for us to learn. We can't expect the machine learning engineers just to come into our world. We need to step into their world as well and understand their concerns and know where they're coming from and start figuring out how we can help them and also sort of improve their ways of working. We can only do that if we know what it is they do. So, to kind of wrap up, I got some takeaways. No surprises. It requires a collaborative approach. That's pretty much what DevOps is. You'll need to make sure that you have all those processes that I sort of touched on in place before you start building models. But having the models is only the start of productionizing it. There's a lot more concerns. Automate as much as possible. That enforces best practices. it makes sure that everything is repeatable, and sort of it'll start to streamline things going forward. And we'll also need to learn new things. Pretty much, that's all we have to do. That's me. No talk without AI and ML is complete without a Terminator. So yeah, I might have about 3 seconds for questions. I'm not sure.